give a live talk. Thamar is an associate professor at University of Houston. She received her PhD from the National Institutes of Astrophysics, Optics, and Electronics from Mexico. Her research interest includes information extraction from social media data, enabling technology for code switch data, stylistic modeling of text, and more recently, multimodal approaches to online content understanding. She's currently the director and founder of the Research in Text Understanding and Language Analysis Lab at University of Houston. She's also the recipient of several awards, including the NFS Career Award. So let's, without further ado, I would like to ask Thamar to join us, and her talk is titled NLP-enabled design assistance for visual communication. Let's see. It seems Thamar just required a second. There we go.
I'm here and I am sharing. So please let me know if you're not able to see my slides. Otherwise,
right.
I will get started.
Thank you, Thamar.
Right.
Without further ado.
Thank you. Good morning, everyone. I'm very happy to be here. Thank you to the organizers for inviting me. So I'm going to be the oddball here in this session, not just because I'm giving the live talk, but because I steer away from the original topic. Today, I'm going to talk about the work we do with NLP to support design assistance in visual communication. So in visual communication, the intent is to portray information in a graphical way. And when we talk about text, what that means is that designers use font and special formatting like colors and size in order to give an appealing version of the text, but also one that supports understanding. That's the primary goal, is to do understanding. And so my group, in collaboration with people from Adobe, has been working on this space, and I'm going to be talking about some of the work we have been doing in this space. So first, I'm going to start with a counterexample. So when things go wrong, like when design and meaning intent is not actually matched together. So if you see this sign, if you can hopefully read it, and you see that the special formatting here actually turns what is intended to be an innocent title into something that is not. So that's a counterexample. Here's another one that is less gross or like subtle. If you see these two different covers and you read the message, most of you probably would agree that a better design for this text is probably the one on the right. It kind of better matches what is the meaning of the text. And so this is what we have set out to do. So we are exploring how we can use NLP to support content creation. So the goal is to make the content appealing, eye-catching. We want to grab users' attention, but we want to support efficient communication. We don't want to do it in a way that it distracts or that it changes the meaning. I want to mention again, this is a collaboration with a wonderful group of people that I'm showing here. And also clarify that we're not concerned at this point with the content itself. So we assume we have the content, and we want to beautify it in a way that supports understanding. And so we see this as a nice intersection among graphic design and NLP and among other fields as well. So what I'm going to do today is present initial results on two tasks that are related to this idea of, supporting visual communication design. Both of these tasks will focus on English only. As a beginning, for these efforts, we have collected and annotated data, but it's only in English so far. And then I'll discuss what is coming up next in our research agenda. So I'll start with discussing emphasis prediction. So by emphasis, we mean the use of special formatting. Like if you see the text on the right, the word camera has a different color. So we are highlighting the word. And we assume that emphasis clarifies the meaning of the sentence. It draws attention to specific words in the text. So what we want to do here is that we want to analyze the short text and we want to suggest which words should be emphasized with special formatting. And here's an example. It's the same phrase, but we can see different types of emphasis. So there are multiple applications for this type of task. We see this short text with design in a lot of graphics, a lot of Facebook posts, flyers, Twitter quotes, book covers, and all of these advertisements, right? And product labels, for example. They all use supporting text and they all want to use some type of special or style in the text to make it look nice, but also, again, to make it understandable. So, and there are some existing algorithms that work on this, that try to support the user for this task. But what is out there, so far as we know, it doesn't really include understanding the text. So, for example, if we think about an example application would be Facebook. When we try to write congratulations, for example, in a post, like Facebook will suggest a special formatting when we write the word congratulations. And so as far as we know, that's based on fixed lexicons of words that probably the user would like to emphasize. Other applications emphasize or suggest the user to emphasize words randomly based on something that is not related to the meaning, such as the word length. And as we saw at the very beginning, if you use a wrong formatting, a wrong emphasis, then the text could be misinterpreted very easily. So some considerations for this task of emphasis selection is that we are limited in this setting to just the text. Most of this visual communication will have images and will have some other colors in the background, where so far it's considering text. The data sets are very short text, usually less than 10 words. And we also need to clarify that we see this as a highly subjective task, right? Style and designing this type of tasks will be user-specific, also general domain specific to where it is being applied. And what we look for here then is a model that is able to handle this subjectivity, right? Because even though there may be a variety of preferences, it is also true, our assumption is that there are some choices that are just plain wrong, that users will never choose. Also, for this task, we have studied the data sets that were annotated, and emphasis words are not necessarily related to frequency. So they're not always the most or least frequent. And we want to highlight that this is different from keyword extraction, because in keyword extraction, primarily the goal is to extract the words that represent the text. And usually these are the nouns and noun phrases, whereas in emphasis selection is not tied to a specific power speech tag. At least we haven't found a strong correlation. So in order to explore this task, we created a data set. We were not aware of data set that exists. And so we collected around 1,200 instances from Adobe Spark. These are short texts from advertisements and other types of short text. And we turned this into a sequence labeling task. And we asked 9 different people, because we assume this is a subjective task. We request 9 different people to see the text, read the text, and then tell us which words should be emphasized. And so if you can see here, the words "enjoy the last bit of summer," then different annotators will have different preferences here. And then what we can do with those preferences is we can calculate the frequency for each of the tags, as we see here. So for these words, 6 people chose this as the beginning on emphasis, and 0 people as the inside and 3 people as other. We can also normalize our frequency. And then we can turn it into, we can collapse the B and the I into just a binary task. Should we emphasize the word or not? And then we can calculate the probability for the word to be emphasized. And so because of this subjectivity, we don't want to treat this as a hard labeling task, because again, we think that we should allow more than one possible choice. And what we do there is that we label this as label distribution learning. So we have a probability distribution over the labels for the words, and then we want the algorithm to learn over this distribution. So our first model is actually quite simple. It's an embedding layer that fits into a BLSTM, then goes into a dense layer to make a prediction. This is, again, we created the data, and then our first try is to do the simplest thing that we could do. But we compare against conditional random fields, again, because we treat this as a sequence labeling task. We give features such as the word or speech tag information and so on. And for evaluation metric, we look at match M. So match M is a metric that we design that is basically just measuring what it says here, the average of intersection between the M most frequent choices by the annotator and the M most frequent predictions, or no, not the M most frequent, the M top probability labels for the model, and then normalized by the sum M, and then average over the entire set. We also compare against the top K. So top K is just taking the top K words in my gold standard, the top K words based on probability for the algorithm, and then the F measure computed over those top K. So here's a table with results. I'm just showing a fragment of the results. If you're curious to see the rest, then you can look at our ACL paper from last year. Basically, what we do, we compare, using soft labels like this with label distribution learning against hard labels. So what happens is we just take the most frequent label from the annotators and the most likely labeling from the model. But when we compare results, it turns out that this works better. And as you can see here, both embedding models, one using Globe and one using Elmo, outperform a conditional random fields classifier. In this case, we find that Elmo embeddings were better than Globe. And the results are statistically significant with respect to a CRF. And so here's an example of the models output against the ground truth. So the coloring, the darker the color, then it means that the model is more confident or a higher probability to select these word stories against these others. And then here as well, this is the distribution of labels across the human annotators. Darker colors means that more people agreed on this set of words. And so as you can see, we look at the darker color words. They are highly correlated with what the algorithm is choosing, what the annotators did for this, for the most part. They seem to be aligned. And so we thought this was an interesting task, and but again, it's a small data set, and it's also we want to encourage more people to participate in this. So we annotated more data, and then we created a Semival task. We hosted task 10 for Semival this year. So now we have 38,000 instances. So we have Adobe Spark data, but we also collected inspirational quotes from internet. And then we hosted a competition. We had a reasonable interest. So we had over 30 teams that submitted system predictions and their descriptions. They outperformed the state of the art. So state of the art for that chart was our previous system, the one that just mentioned. And so when we average across that system, across all the new instances, it achieves 0.75 performance. And now the system that is at the top of the leaderboard has 0.82 performance. And so I'll just mention very briefly what they did. The actual Semival task is not presented until calling. So it will be, our overview of the task will be presented soon. But what we noticed is that the top systems were using a combination of contextualized embeddings like Ernie, Bert, and their friends, plus some handcrafted features like battle speech tagging information were used. So here is just to show an interesting fact about the breakout of what system participants did. So it's a pie chart showing which embeddings are being used, just because that's one of the more, I guess, distinguishable characteristics of the different systems that participated in our chair task. And we can see that, Bert is dominating in this particular chair task, followed by Roberta and then Elmo. And so more of this is going to be presented at our overview paper. So for this part of the task of the talk, which is, what we did is we introduced a new NLP task, emphasis selection for short text instances. We hope that people keep working on this task and that they will use our data sets. We released a new data set that we just created a labeling system for label distribution learning for this task. And so I'll move on to the other project that is related. So when we're talking about emphasis, of course, users have a multitude of choices, right? So they can boldface, they can underline, but they can also select different fonts. And when we're talking about fonts, there's like an abundance of different fonts or typefaces that users can use, right? Here's a very small sample of different fonts for the same text, but we have thousands and thousands of fonts available when we're designing. And so if you're like me, when I am writing my slides, for example, I don't want to get too complicated, and I will go with default fonts. But for advertising, again, visual communication, graphic designers, they do need to be more creative with what they use for their fonts. And so it turns out actually that people have found, recent research has found that users can agree on assigning personality traits to typefaces. So users agree on assigning abstract characteristics like, this font is delicate, this font is dramatic. They can also describe a font with more specific attributes like cursive or theme fonts. There's also previous research by Gerard de Mello's group, where they have shown associations between words and fonts. So semantic association of specific words to fonts. And more recently, they actually came up with a paper where they are supporting user discovery of fonts. So in this case, the user provides a font and says, I want to make this like a happier font or like a more playful font. I'm just making out the attributes, but it's something like this. So the user guides the discovery of the fonts. What we try to do here is that we actually try to embed some language understanding into the font selection process. And so again, for this, we didn't find existing data sets. We take 1,300 instances from Adobe Spark, and we don't just use any type of font because there are just too many. So what we did is in consultation with graphic designers, we select a set of 10 display fonts that are sort of like representing families of fonts, right? So we have numerous types of fonts, but many of them are related. And so what we did is that we extracted 10 display fonts that are kind of like a representative of 10 different families of fonts. And what we do is that we show the text, these 13 instances of text to different people using each of these 10 different display fonts. And we ask people to select their top 3 choices. So if they look at the text and they look at the font, tell us which is the one that you like best. And so here's an example of what we have in the data. So each of these colors represent one of the fonts that we have from F0 to F9. The part on the right, the part on the right shows the same text using each of our different 10 fonts or typefaces here, so you can see them. And here in this graph, what we show is that, oh man, For this particular here, for this particular text, like 27 most influential small business blogs, this is the distribution of labels that the users selected. And then for a different text in our data set, for like my first surf day, this is the distribution we observe. And then for another one, we observe this one. So what we try to show here is that for different types of text, users actually exhibit different preferences. And so you can consider, for example, that this is like a more professional career-related type of text. And then users tend to prefer something like F2, which is this one, and F5, which is this one. Whereas in something that is more like personal, like I love you, mom, the users tend to have a stronger preferences for something like F4, like a cursive kind of text, like more intimate type of text, of font, for example. And so there seem to be some patterns, and this is what we try to capture. So if we can sort of understand what the intent and what the content is, can we select it? Can we give the user a good choice? And so for the approach and evaluation, again, because we assume that there's subjectiveness here, then we don't want a single one. We want to give options. So we treat this as, again, self-labeling. We want to learn a distribution over different fonts for the text. We use a similar type of models, but in this case, we do explore models like BERT. So we have BERT, we give the output of BERT to a dense layer, 2 layers of fully connected layers, and then the prediction. We also try using a deep emoji representation. So deep emoji representation gives you an embedded representation for text that is supposed to help predict the most appropriate emojis for a text. And so again, because previous research shows that fonts can be associated with emotion or personality, we assume that a representation that is based on emotion can be helpful. So we try using the emoji, the output of the emoji model into a dense layer in a prediction. We compare against using Globe, similar model that we did before. And then we also explore the NRC emotion lexicon as a representation for the word. So that is a more traditional approach to measure or represent emotion in text. So here are the results that we have for this particular type, for this particular experiments. Again, you can see the rest of the experiments in our ACL paper this year. I'm showing font recall. Font recall is calculated as is here, the average recall for each of the fonts. And we calculate font recall because there is a skew distribution. So users tend to prefer some fonts over others. And what we want to avoid, or we want to ensure that each of the fonts is being learned by the model. So if you can see here, for example, if we have a majority baseline with the top 5 fonts, we get 50%, top 3%, of course, that will be 30%. And then we also have the weighted F measure for, again, the top 3 fonts for the annotators, and the system, the top 5 annotations. And so we have here a subset of the results. All of these embedded representations achieve better results than a majority baseline. And in boldface, we see this one is significantly better as well than the majority baseline. But the best results are using BERT. Although if you can see, BERT and the emoji actually are very close to each other, and which is, again, this supports our assumption, and it goes well with previous work that actually discusses this idea that fonts have personality traits or can be described with emotion type kind of attributes. So, okay, so again, for this part, we propose and formulate a new task and font recommendation from written text. We have a new data set that is released alongside our paper and our code, and we show that emotion-based models like the emoji are actually competitive when we compare them to BERT-based models. So our ongoing work, we want to extend the work. We're currently working with presentation slides. So can we select, predict emphasis for presentation slides. We are annotating data, and we are designing appropriate evaluation approaches. We are also currently exploring the formulation of emphasis task as a Q&A task, like which words should be emphasized, and train a model for Q&A in this fashion, since we have seen good results along these lines. And of course, in the future, we would like to expand this to actually suggest the types of emphasis. So maybe like a personalized emphasis predictor. If I like boldface, then I can predict emphasis, and then the system can suggest to me to boldface something. And if a user likes to underline more, then maybe the system selects that. But maybe also, why not try to learn the whole thing? I mean, again, this is initial work, but we think that in the future, little by little, we can get to that point. And so I'd like to take the opportunity to plug in an advertisement for our event. So we are hosting a workshop on AAAI on content authoring and design. So we want to get the community together, community that are interested in this type of research. The submission deadline is November 18th. And then we are also hosting a chair task on this emphasis selection on presentation slides. And so we are releasing the data set today. So there's a link if you want to take a picture, grab the QR code and participate. There's still plenty of time. And so hopefully I will see you in February at AAAI. And with that, I would like to thank you for listening to the talk. Thank you again for inviting me. I believe at least one of the co-authors is in the audience. So, I will invite him to also join us during the Q&A. So I'll hold now and I'll take any questions if you have.
Awesome. Thank you so much, Thamar, for the great talk. I would like to also invite the other person that, Thamar, you mentioned, of your colleagues for the Q&A section. If you have any questions, feel free to put it on the stage chat. Let me see through them. So Aditya is asking, how expensive is the annotation process? Would it be an approach that you would recommend expanding?
So we use Amazon Mechanical Turk, and because we are using Amazon Mechanical Turk, it's not as expensive. If we were to actually bring people to the lab, I would imagine that would not be something we could afford on an NSF or a university budget. But we believe this type of data, you should have a good number of annotators. So if you want to go this way, then there should be some investment into proper resources.
Thank you. Avijit Tawani asking, do you know of research products that experiment with dynamic emphasis? For example, a GIF-like medium which shows typing, deleting, rewriting of text.
Not really. But again, maybe just my ignorance because I don't do graphic design, so I'm not fully aware. So the closest I'm aware is, again, when I mentioned examples like Facebook, where it shows you suggested highlighting and, effects, special effects for some of the words, right? Not really sure what else is out there.
Got it. One last question. Rami asked, did you experiment with cross-lingual models where you can transfer the prediction of word emphasis into another language across parallel text?
No, great question. We haven't. Maybe we can try it together. We just have stuck to English, unfortunately, so far.
Got it. Well, thank you so much, Thamar. This concludes the first session for today. We had 3 great talks.